So let's continue with the second component of the programming, B. Okay, B is how do computers fit in with the world around them. So this is a long sentence. In word, it's just like how to build a mathematical model or computer model. That means modeling, correct? Modeling. So in fact, now the most popular computer modeling method is OOP, OOD, correct? Object-oriented programming, object-oriented design. So in fact, here we also use the OOP, OOD in the JavaScript-based programming, JavaScript and JavaScript-based programming. For example, here is the model of a hotel. Okay, we want to create a mathematical or computer model for this hotel. So this hotel has some trees and also people and cars. Okay, and also we know the name of the hotel is Quay, Quay. So that means how to represent these things in the computer. Of course, for a hotel, we don't care about the 3D model. We care about its functionalities. For example, how many rooms are already booked, occupied, how many rooms are available, and whether we can allow a person to book, and the price and so on, correct? Like these things, and then cards information. Okay, so here for human, it's clear what kind of a real-world object each one represents. For example, we know this is a hotel. Okay, this is a car. This is also a car. So though there are the two instances, we call it two object instance, but the type is the same. Their types are the same, which is a car, correct? So, but computer don't know, correct? We know this one. This one is a semantic concept. So we want to build a mathematical model to handle this one. For example, for hotel, which data we need to save, which functions we need to code, we need to provide to change the data. And the car is the same, correct? Which data we need to provide and which function we need to provide. So for hotel, we mentioned about the rooms available, correct? We can book, we can cancel. Cars, for example, you need for what is the model, correct? What is what's the make model and the year and how many engines and so on. And then we can speed up the car, we can brake a car. So these are the operations we can do. Okay, so that's the two main constraints. First one, which data. Second one, which operations. Correct. So data we use we save them in the object, and then and the operations we save them as well. So you need to define a class, object class. We define its data and the functions. Okay, methods. Okay, we call them methods. Let's continue. So computers need to create models of the world using data. So here means the data is all the different type of data because we use computer to process data. We don't care which type of data, but they will be stored as data. Can be numeric, can be just some literal data, just descriptions, kind of property. So basically, how we represent data, we usually use property and value, correct? So this is same as the previous. For example, like we mentioned in the HTML. So we have property and its value. So this is a pair, correct? It's a pair. Okay. So here we said the objects in this model use properties. Okay, that's the data. Events. So events means some operations which can change the state of an object. So this is like a message. You have object here, you have object here. In between, you need to use event to change the state. Okay? For example, you have a car. I brake the car when it's running. So this is braking is an event. And I accelerate the car. So it's also acceleration is an event. And the booking a hotel, the booking is an event. And then methods. So that means after you receive the events, what's the things you need to do? So we need to code in methods. So methods just like a response to respond the events. Okay, responding events. So this is like a data methods. Okay, we code this one. So in an object, we have data, we have events, we have methods. And then between objects, we use events to drive the the running of the system. Okay? So you call it events driving, events driven messaging. So that means events will go through different objects, and then when an object receive an object, in fact is object instance of object receive an event, it will call the methods, call the corresponding method to change the state. Okay, to change the state, you need to change the data. Okay, change the data of an object instance. So this is how we understand, or how we code the physical model in computer. Use a computer model. So that means we use this terminologies to describe this OOP. Okay, use properties, events, and methods. Sometimes in the OOP we set data, events, or messages, and then method we set. Sometimes we use functions, but yeah, methods may be more popular. Okay, so let's look at the properties first. Properties tell the computer about the characteristics of an object. That means the feature, right? Like a hotel, like a car. So it's a static or dynamic feature. But we can change the even some we can change, some maybe not. For example, the building year, the year of the building, the hotel, the year of the car, the model, the make, and so on. This one we cannot change. But like the speed of the car, and the available rooms, and occupied rooms, like this, the number of bookings, and so on, like this thing we can change. Correct. So, for example, we still use a hotel as the example for the following several slides. The first one is we have this name is this one, rating, how many stars, rooms, how many available rooms, and the bookings, that means currently how many bookings are there, and then whether it has a gym inside, whether it has a pool inside. So all of these things are the data. Okay, so that means we have the properties, we have the values. So it's a pair. Okay? We give a name to the property, to the attribute, and then we set the value for that attribute to differentiate this one from others. Okay, so this is about a property. And the next one is the events. Events tell the computer how the user can interact with a object. We mentioned about based on the events we can do interaction, because for example people will interact with other people, with other objects. Correct? So that means interactivity is very important. So how to drive the interactivity? So we must send events. In fact, it's like a message. When you are in a car, you are driving, you want to accelerate or you want to brake, so you press which pedal. Will decide. Okay, if you press the oil pedal, that will speed up. If you press the brake pedal, that will brake. So this is like you sent a event to the car, and then the car will respond accordingly. It will either speed up or slow down, and then the speed of the car will be changing. So you will need to set a new speed, get updated speed, of course, based on the time. So that is changing every time. The speed is changing, and then it's going up or going down. Okay, that's the events. So events will drive the state change. If there is no events in between objects, you only have objects, they don't have any intersection, so they will just keep staying there. So as static one, cut static. So of course that is a lot amazing. Unity system is a dynamic system. We can say the static system is only relative static. We don't have a absolutely static system. Okay? Like even you are sitting in a chair, you are still moving. Okay? So you know our planet, our Earth is moving all the time. So we can only have a static one. So the dynamic systems is more popular. Okay, and also Unity we must do the changes. We can do something. Right? We don't if we don't do any change, nothing change. So there's nothing interesting. You cannot achieve the goal. So why we every day we are learning. So we are changing. Right? If we stop learning, we don't uh, we don't do any change. We're static in our knowledge. Okay. So let's look at these events. For still use the hotel. For example, you can book a hotel room. You can cancel a reservation. Correct? Book room or cancel. Maybe one or two. Correct? It depends how many. Maybe. So, but anyway, it's a reservation. You can book a reservation. You can cancel a reservation. So we can understand. Okay, so that means this hotel object can receive that event from other users. It book means it allows you to occupy some rooms, a room or some rooms, and then cancel it will empty out. Set the rooms are empty. Cancel. Right? So when we do the booking, we do the cancellation. We need to confirm whether we allow you to book. If we don't have any room available, okay, receive this event, but check the data. All the rooms are already occupied. So even you know this fact, you send this booking, and then it will be rejected. The reason is that they will confirm whether this booking will be allowed or not based on the data. So they will have a function there which handle this event. Booking, okay, cancellation, okay. We need to handle them in a legal way, whether it's legally allowed or not. So this one, there's a script there to handle this one. Okay, so that's the methods. Okay, so methods tell the computer how to change the properties of an object. So we mentioned that you can only change the property, the values. For example, the hotels, how many rooms are available, how many rooms are occupied, and the car, what's the speed, what's the current speed of the car. So this is what we can do. Okay, you cannot change the methods because the methods just handle the events to change the state, change the properties of an object. It may change others as well, but it will mainly change itself. Change itself. Okay. For example, still hotel, we allow the booking, make a booking, and this one we increase the value of bookings. Okay, that means the number of bookings, and also we do the following. That means it will increase the number of occupations and reduce the number of rooms which are available. Okay, so that means this is make booking, increase the value of bookings. Okay, for this one only do this one, but also change this change accordingly for the property. For example, for the cancel booking, this one will decrease the value of bookings property. So that means the number of bookings will be reduced because there's a booking which has been cancelled. And then check availability. This one will, of course, will be the total room minus the number of bookings. Okay. Subtract value of bookings property from value of rooms property, and return the number of rooms available. That means the total available rooms. For example, for this one hotel, in total we will have 200 rooms, and then we have 100 bookings, so we only have 100 rooms for the availability. Okay, so this is the idea. That means when we receive an event, we have a method. Okay, the booking first one we do this one, increase the bookings, and the second one they will decrease the number of increase the number of bookings. So that means the number of available rooms will be decreased. Okay, you can just save only one data, but anyway, okay, we'll do like this. We'll check the availability, whether it's available or not. Okay, so here we talk about the cars as well. Another example, for example, the car. Okay, this is a car, and then we put all the things together at here. So we have properties. Make is BMW, and the current speed is 45 miles per hour. Color is silver. Fuel is diesel. Diesel is quite special. And the method event we can brake, we can accelerate. If we brake, so that means we want to slow down. The method code will be change speed. Okay, if we brake, we change speed, can go up, can go down for the change speed. And then accelerate, the driver want to speed up. Okay, it will also change speed because that's the resulting outcome. And then the method for this one, we'll do this one. Okay, change speed, increase or decrease values of current speed property. So that means we adjust the current speed based on whether it's braking or accelerating. It depends. Okay, they will handle this one. That means how many miles will be increased or decreased. It depends their method. But anyway, we just look at the overall, the high level implementation. That means it contains properties, methods, and events. For example, when we do the braking, the driver slows down, and then we change speed. Okay, change speed we'll do here. So this one, of course, will decrease the current speed. For example, current speed is 45 miles. After you do a brake, and then current speed will be dropped to 30 miles. Okay, so just show you a demo like this. So this is tell you how these things interact with each other. So events will call the methods to change the properties in a word, just like this. Events will be received by an object instance. Events are the driven factors between objects to change the system state. And the methods are the only way to adjust, to update, to change the values of properties. Okay, properties are already created. When you create an object, it contains both data and methods. And also the methods will just listening to the events. Okay, listen to the events. The events received, it will call this one. So all of these things just like a script. It depends. Okay, if you change speed, can be a breaking event, can be accelerating event. So maybe they will call different portion of the method. If we use a script to write the method, they will run different component, different portion of the method. That's how we handle this one. Okay, we pre-defined the response procedure for braking and accelerating in a script change speed, and then we can do it. We can follow the procedure to response. So that's why you can find how stupid of a computer can. They can only do by telling exactly what they can do. So our people are smart, people are bright. So we need to know how to simulate as real as possible systems in the virtual world. That means the braking, and then the strength of the braking will correspond to the decrease of the speed. So what's the function? Corresponding function. You may have need to do research in this part. Okay? They may be not linear, so you need to build a mathematical model and then code it. So that's what we need to do. Okay, this is the first part, and then we'll continue with the second part for the web browsers. It is also utilize this object model. Okay. So here we talk about web browsers. Okay. So in fact, web browsers as a in default, it is also an object. Okay. We have learned, for example, we have learned Windows-based programming based on the MFC, okay, Microsoft Foundation classes. Okay, so that means you have a window, and then window and the other windows, they can use events to communicate. Okay, so a window also has its properties. For example, what's the position, what's the size, width and height, and also background color and so on. And also it can do some functions. For example, if you zoom in, you exemplify, or you squeeze it, it will change the size and then redraw it. So that means itself as well object. Okay? Web browsers use these models to understand how to interpret web pages. So that means in a web browser you can open multiple pages. Each page is an object. Is it correct? So we can open multiple tabs, and each tab is an object. So that means we just build the concept like this. Okay. For example, how the browser process the page. For example, how the browser can draw the page. The first one is that the browser will receive a web page. Okay, so the browser, you will open the Google Chrome, Google Firefox, and so on, and then you click a link. You open usm.edu. Okay, you click this one. The browser will receive this one, or want to open the USM homepage in my browser. Okay, receive this web page. Receive this request. For example, here. Okay, this is the USM web page, for example. Okay, and then the page itself has these contents. These contents show very basic structure, but will be enough for you to understand. For example, here we have a document, we have a head, we have body, and then in head we have a title and link. In body we have H1P and the EM, okay, like these components. So we can build a hierarchical tree for this one. That means how we represent this web page. So that's the second step. we'll create a model of the page and store it in memory. So the model of the page will be called a document object model. Okay, so that's here. Document, that means the HTML, the code, the whole page, the USM page. In the page, we have HTML and the header and head and the body. In the head, we have a title and link, and then in the body we have H1 and the P, right? And so on. So this one, okay. So this ones you can find this one is the object, the high level. Inside of it is called element. You can just think about attributes, okay. And then for these ones, the values, okay. So for the elements, they have this value, okay. We set it as text. So that means we organize, of course not completely like that, but we organize the web page in this document object model. Okay, we save this one in memory, and then we can redraw it in our browser because we have saved the page structure and the content. Okay? So semantics and contents, we save them into a object mode, document object model, DOM. Okay, later we'll talk about this one. I think in chapter 5 we'll just cover this. Yes, chapter 5 we'll cover this model in detail. Okay, and then we have attribute as well. This one is a lot of text. It only show the attribute related to some element. For example, link to a CSS file, and then this is the attributes for the link. So it's related to style sheet. Its path is this location. This is not a text because we will not show this text on the page, but we have these attributes. So this is how we represent. And after that, we said if you have data structure encoded and then save into the memory, okay, model for this one is DOM, and then save in the memory, and the next one you use the browser engine to draw it. It shows the page on screen using a rendering engine. Okay, that's easy, right? Because you have contents, you have the structure, you have the formatting, and even later we talk about it, you have the methods, the scripts. Okay, the next one is just draw it. So render this. Okay, so that means we redraw the HTML, redraw the web page in your browser from the user side based on the downloaded data and code. Okay, we build a model, save into memory, and then we draw it. Okay, so this is the idea for these basic things in the B part. Okay, in the B part. So we already exhaust all the time. Okay, use all the time for this one, and the C part will be relatively simple, and then we'll cover that part in our next week's first instruction video. Okay, so this is all for this class. Okay, have a nice weekend.